Okay, I'm back. Can you guys hear me? All right. So, my buddy Faiz, what's up, buddy? Yeah. So you're asking about the analyze malware script, and yes, the analyze malware script. You're gonna have to wget it right here. So even if you don't have the virtual machine, this is what I was talking about, where you should be able to run most of the stuff without my virtual machine. Yeah, so just yank that file down. Okay, so now what we want to do is we want to jump down here and do some quick install stuff. So we're going to do a sudo apt-get -y and install PE file. So it's going to be this number right here, line 68. Okay, let me know when you guys have that installed. No, it's not all file. That's what's called OLE file. Looks like you have to pip install it. Try that. Alright, looks like that about does it. So we just need to make this one little change right here. Looks like I'm trying to run the control. Okay, so back to business. All right, so what should have happened now is you've already ran Analyze Malware, you already downloaded it, and you installed Python PE file. So what we want to do now is we want to do line 70 in di analyze malware.py. Now you can do shift:set number, and then add some line numbers to it. So we're going to scroll down a little bit. We get down to line number 33. So while we're looking here at line number 33, can you see that we're going to import OS, we're going to import sys, we're going to import RE, we're going to import string. So OS for operating system, sys for system, RE for regular expression, and string for dealing with strings. We're going to create our first function. So in Python, when you define a function, you always define it. So define check_config. So there's a function called check_config. So this is the calling of the function. You're going to put it in what's called a try except block. So you're going to say try to do this. So you're going to import these PE and PE utils, PE file modules. Now, did you notice I did a Python, apt-get install Python PE file a little while ago? We did that first. That was the reason I made you do that, because I wanted this import to work. So it's telling you here, go ahead and get this PE module if you don't have it already, but we just installed it first. That's the reason why we did it. So now right here, this except block isn't going to run because this should have successfully imported. Now, if it didn't successfully import, you're going to get this message, PE module missing, download it from here, and then exit. Sys.exit is 0. See that? So that's how it closes. That's what that import sys was for. So now we get down here into line 47 where it says say hello. So you see where it says if sys.platform equals Linux or sys.platform equals Linux 2 or sys.platform equals Darwin. Darwin is for Mac. So you see that? Right, so Mac is also called Darwin. So what he's trying to do when you look at this code, if the platform is Linux, if the platform is Linux 2, or if the platform is Mac, we're going to create a variable called syscls, right? Basically system clear. How does that particular system clear the screen? And it's going to use clear. Else if sys.platform is Win32, or if your sys.platform is DOS, or if your sys.platform is MS-DOS, the way that you clear a screen in Windows is CLS. Now, if it's anything else, he's like, hey, man, I don't know. So that's why immediately after that, he runs os.system. So os.system is how you execute stuff from the command prompt. So whatever's in these parentheses will be executed just like it's running from a command prompt. So Now he's going to take CLS, and if you're Linux, Linux 2, or Darwin, he's going to run clear. If you're Windows, he's going to run CLS. That's what's happening right there. So that's a cute little way. It's a cute little way to clear the screen. That's all he's doing. So he's just clearing the screen. Now he's going to create a list. In Python, whatever's in brackets, we call that a list. So it says create new text, copy file, create file, NTAFSD, NTASDF, create file, call shell32, advanced API 32.reg OpenC. Okay, so what's up with that? Advanced API 32 is a DLL file. Let's take a look. So Advanced API 32 is a DLL file. Now, when you see a function that comes after it, so for example, if it's advanced API 32.reg open key, like this, see that? So reg close key, reg open key. In other words, that DLL, advanced API 32, inside of that DLL, right here you'll see that call to reg open key. Just like the same thing, we've got kernel 32. You remember our DLL, kernel 32.dll. Inside of that DLL file is a function called create process. So we've got another one, right? So this is a COM component, right? Shadow CW. So in all these cases, get host by name, right? This is for network connectivity. Now here's one, ws2_32.bind. So you remember we found our DLL, ws2_32.dll. Here we're looking for functionality inside of that DLL. So we're looking for the bind functionality. Maybe it binds to a socket. Maybe it listens, ws2_32.listen, ws2_32.htime. Now here we've got another one, that advanced API reg create, reg set. You're also looking for, do you see cases of web URL? Do you see a call to a socket? This really crazy rigmarole is an IP address. So you're going to see these types of regular expressions for IP addresses. Let's see if we can figure out how this works. Okay, so here's my first dot. So I'm looking for any number, or, that's what this type is, or 2 and any number, or 2, 5 and any number from 0 to 5. So here's 2, 0 to 4, or any number from 2, 5, 0 to 5. So it can take up to 255. That's what that's doing. And then he's doing the same thing. You notice it's just the same one over and over and over. So up to 255 dot, up to 255 dot, up to 255 dot, up to 255. Right? So it's just a way to look for an IP address or subnet mask. So here's something that your malware might be doing. It might be getting environment strings. There's an interesting one. Load library A, WSA socket A. Here we go, get proc address. How many of you guys are starting to notice that this is the stuff that we were grepping for? Anybody picked up on that? This is all of the same stuff we were grepping for, isn't it? So what you're doing is you're taking all of the stuff that you would grep for, and you're putting it in a Python script, telling it to go look for it. So here's an interesting one. Is debugger present? So here, this is how we determine if the current process has a debugger attached. So if you do your string search through this malware and you see that it's got is debugger present, you now know that the malware can detect if it's being analyzed. Let's check out some more stuff. Okay, so he's looking for interesting DLLs. Kernel32.dll, Advanced API 32.dll, COM Control 32.dll, GDI, there's that graphic display interface, right? Object linking and embedding, OLE. Object linking and embedding authentication, OLE off, right? User DLL, WSOC32.dll, MQDLL.dll, right? Registry keys, HKey current user, HKey classes root, online stuff, IRC, join channel, port, bot, flood, DDoS, NIC, right? Join, invite, everything. So it basically just has a list of stuff and says, hey, if you see any of these, let me know. Now, pretty interesting, but let's get down a little further and see what it says. Okay, so if length of sys.argv is less than 2, so sys.argv is argument vector. This is how you pick in stuff from the command prompt. So we basically run it by saying analyze malware and then the malware file. Okay, not too bad. Looks like the for arg and sys.argv, if the arguments are -- help, it prints this out. Okay. So it looks like you can say -- DLL, -- header. Okay, well, let's go take a look. Okay, so malware equals sys.argv1, right? So the first command line option. So we try, we call it hosts, open malware, open it as read lines. Now, if you can't open it, you say, hey, there's no file, and close, sys.exit. So now we have another function, and the function is called def start analysis system calls. So you say, okay, performed for line in host, right? Host was the malware. So you're going to remember we called host malware right here. So you're going to say for line in host, do something. So you go through every line in that file malware, which is host. For calls in registry calls. So if you go up to registry calls, you have a list of registry calls. Here's your list. So you're going to look through every line of the file and see if any of these in line 74 are in the file. Now you say if re.search calls is in one of those lines, right? If re.search calls line, if not calls in performed, print found an interesting call. Then you do performed dot append calls. So basically what you're saying is if one of these is not in, it's a whole bunch of double knots to equal a positive, right? So basically, if I see one of these lines on my list of registry calls in the file, say that I found it, right? It's a whole bunch of double negatives to say that, but that's really what you're doing. Now, I want you guys to look at how start analysis is. Matter of fact, compare the two. What can you guys tell me about the start analysis system calls function and the start analysis registry calls function, line 102 and 112? What can you tell me, guys? See anything interesting? Look at line 102 and 112. Okay, so we can definitely see that's what it's doing, right? Anything specific about that code? Like how different are those functions? Or did he basically copy the same function? Yeah, he copied the same function, didn't he? Right? Def start analysis system calls, def start analysis registry, okay? Now the next line below performed, or line in host, or calls in registry, if RE search calls line, right? I mean, it's really the same function. Now, here's where we get to an interesting one. Def calls to DLLs. If sys.platform equals Linux, or sys.platform equals Linux 2, or platform equals Darwin, string objdump -x on that file, grep for DLL. And then he's going to print, since the OS is Linux, performing deeper analysis. So he's going to say details, we'll call os.system string, right? And that's that running the object, the objdump-x, right? Then he calls DLL result, open result. This is the file that he made right here. Open result with an R read line, and he's going to print it. Your DLLs are, and then he prints out the DLLs that he grabbed. And now he says for line in DLL result, print the line. Then after that, he does os.system rm result, where he deletes that file. No, that's not what's going on, Patrick. So Patrick says dig deeper as DLL is not routinely loaded in Nix, so we need a bit more info than Windows. No. What's happening is because we're running this script on Linux, we have access to the objdump command. That's all. So in other words, if you notice everything I taught you, this script is automating. I taught you how to do all the string stuff, and I taught you how to do the objdump. You're noticing that's what this script is doing. So he's doing objdump to get the DLLs. He's doing objdump to get the import address table. He's doing objdump to get the start address of the file. He's doing objdump to get the header information. Right? He's doing objdump to do an ASCII dump. Interesting syscalls. This is how I can figure out if it's part of a DDoS network. If you look at those syscalls from earlier, they were things like ping and telnet. Start analysis online. Okay, so this is where it's looking for all those IRC commands. So you see how it's going to print. Malware seems to be IRC bot. Okay, def get signature for PE, try signatures equals PE equals signature database, return signatures path, set, right, def get PE signature, PE equals PE, malware signature info, PE info dump. All that grabs is just your PE header info. So now you have a function called check PE. This is how it makes sure, whoops. Okay, here we are. Generate a dump. You guys keep noticing there's just a ton of objdump commands. Check PE is how we just make sure that we see that MZ. See that? So yep, it's a valid PE file. Okay, checks for arguments. This is just, did you say dash dash ASCII? Right, now if you said dash dash ASCII, then he'll do the check PE generate dump. If you want the DLLs, and he's always going to do this platform, then he runs these check PE, calls the DLLs, check header, right? If you do a dash dash header, you always notice that he always does this, it's just that platform stuff, right? And you notice he only does all these check PE header info things because he's on Linux, he's got the objdump command. And then he calls it def app start, right? Check config, check PE, check args. And then the very last line is app start. It starts up everything. Okay, so we escape shift : Q exclamation point. That pops us out of it. It pops us out of it. Now we should be able to say Python analyze malware .py against malware.exe. And now when we run that, we see how it gets us all this information. Let's look at it. So right there, analyze malware.py against malware.exe. Sees that it's a valid PE file, right? Found an interesting call to these, displaying the import address table. Import address tables at ADC2, that's obviously mangled. Displaying the header information. This is all the object. Registry hives, there were no registry hives, right? Online behavior, IRC, admin, bot, join, loaded DLLs. Here's your two DLLs. Right, looking for commands inside of the malware, displaying the headers of the malware. That's it. That's it. So you're looking at that, and not too hard, huh? Surprisingly, not that bad, right? Okay, so now that we can see that, let's get crazy. We're going to do, no, it's not my website. I wish it was, joesecurity.org. Yeah, it's not my website. I wish it was, though. joesecurity.org. Okay, guys, let me know when you guys got there. Okay, once we get to joesecurity.org, what we want to do is we want to go up to the top. We want to click on reports. So go up to the top, we'll click on reports. Okay, so now that we clicked on reports up at the top, I want you guys to find a piece of malware that's interesting. Find a malware report that's interesting, and we'll go through it together. Okay, pick one, guys. Yeah, definitely right, huh, Sherry? Pretty cool behavior graphs. Okay. Ransomware, Martin, which one do you like? Pick one. Locky ransomware, is that the one you're talking about? This one here? Or Tesla Crypt ransomware? Which one? Crypto wall. Where's that at? Crypto wall ransomware. Okay, that's this guy up here. Okay, so let's click crypto wall ransomware. Let's take a look. Okay, so we're going to look through this. Let's see how it goes. Okay, analysis 96483, start time, stop time. Analysis duration was 4 minutes. Report type is light. Sample file is abdulhall.js. Okay. Looks like the analysis system was a Windows 7, Office 2003 Service Pack 1, Java 1.8, Flash 16, Adobe Acrobat Reader 11, Internet Explorer 11, Chrome 41, Firefox 36. Okay. All right, so I'm going to scroll down here. Okay. It says sample drops PE files which have not been started. Submit drop PE files for secondary analysis. Okay. Sample monitors Windows changes. Analyze the sample simulation. Sample sleeps for a long time. Okay. Uses HTTPS for network communication. Okay. Okay, signature overview. Cryptography, spam, e-banking fraud, networking, boot survival, stealing of sensitive information, persistence and installation behavior, data obfuscation, spreading, system summary, SIPs, personal firewall, operating system protection, evasion, anti-debugging, malware analysis, system evasion, cookie and others hiding technologies, lowering of FIS, personal firewall operating system security settings, language device operating system detection. So let's jump down here. Okay, so the first thing I've come up with is it says it's got cryptography. So for cryptography, how many of you guys are like, my God, this sucker is some ninja stuff. You know, my God, we're going to catch some ninja malware. So we get down to cryptography, and we can see that it does look like it uses cryptography. So it says uses Microsoft's enhanced cryptographic provider. So what I'm going to do is I'm going to click Show Sources. So if we click Show Sources, I want you guys to look at these. So you've got Get Crypt User Key, Crypt Export Key, Crypt Destroy Key, Crypt Release Context. So basically right here is inside of this exe, inside of 457.1305.exe was one of these strings. So he's saying, if I see any of these strings, now guys, could you Okay, so first list of interesting calls. Second list of interesting calls to DLLs. Third list of interesting system calls. Fourth list of registry calls. Fifth, I think it's fifth, FTH, right? I can hack, but I can't spell. FIFTH? Thanks. Fifth list of IRC calls. IRC commands. There we go. All right, so I would throw in a sixth list of cryptography functions. We'll call that joker crypto. Now get all these jokers. Okay, looks like we got some duplicates in there, so let's get rid of the dupes. Okay, so it's LS, TR, CMPA. Okay, I made that twice. Get crypt user key, get crypt export key, don't need that twice. Okay, so LS, TRC, NPA, destroy key, release context. So, about every time I have a comma, I'm going to put it with quote, comma, quote, like that. We'll do that. Now we can put quotes on both ends. There we go. Sure looks good to me. We'll grab those. How about I paste those in there? Okay, so that's crypto. All right, let's go back and let's thumb through this guy. Okay, spam, unwanted advertisement, ransom demands. Okay, deletes the shadow drive data. Maybe ransomware. Well, let's go click show sources. DSS admin deletes shadows all dash quiet. How does it do that? Binary in memory, system C, system C, system C, Java path. Okay, he must have caught that with a file integrity checker. Let's see if we can find another one. Shows text on screen which may be used to demand a ransom. OCR results. Crypto wall. Matches crypto wall. Okay. Drop certificate files. Let's see that one. Okay. All right, so now I'm going to jump down to networking signatures. Okay, URLs. Okay, we'll catch these with our other signatures. See any of this HTTP stuff, we'll catch that with our other signatures that we already have. So no need to really worry about that stuff. Okay, what else we got? Let me check online time. Oh, wow. Huh. Oh, that's cute. That's cute. Checks time. Okay. Let's see. Boot survival. Okay, HKey users. Do we have HKey users in ours? Let's see. HKey user, HKey current user. We don't have HKey user, do we? HKey users. We should grab that. There we go. Okay, just create a startup menu entry. Modifying existing services. How does it do that? Okay, HQ local machine. Do we have HQ local machine? Yep, we have HQ local machine. HQ local machine. HQ local HQ users already got that. It's doing a sensitive data. How does it do that? Okay. Systems. It's file style. Data obfuscation. Load library, get proc address we already have. And let's check spreading. Didn't know that. Let's try that. Contains functionality to enumerate or list files inside a directory. You gotta be kidding me. Okay, so find first string. LSTRCMPIA. STRSTRIA. STRSTRIA. It's the same ones, right? I already have an STRSTRIA. Find next file A and find close. Let's get all those. Maybe we'll call that sucker spread. Seventh list of enumeration and spreading functions. Bang. Okay. Now, I won't go too much deeper into this because you could do this all day. But what are you guys noticing that I was able to do with a script like this? Definitely extend it. I used to work at the CERT. So the place I worked at was called the RCERT, Regional Computer Emergency Response Team. I worked at the CERT. So I worked for the Army in Fort Huachuca. And, we did a ton of threat intel and malware and all that good stuff. So it was a grand old time back in the good old days, analyzing malware all the time and tracking IPs and being a packet monkey. And what I'm showing you right now, although it wasn't literally this script, was like what I did a couple times a week. I mean, I can't say I did it every day, but, we had one or two, there were Perl scripts at the time. And literally what I would do was I just kept scouring the web for anything that I could find that was remotely close to a signature. Because if it was close to a signature, I would throw it in my script that did a lot of this analysis for me. So, like, once you kind of got your process where you're going, okay, this malware stuff really isn't that bad when the bulk of it is just string searching. I mean, that's really, seriously, like, it's really just string searching. So the hardest part is really knowing what to look for. So you end up getting really good at knowing your Windows DLLs. I mean, you just got really good at that. So knowing what you know now, you would probably want to extend some of this stuff, right? So you probably want to go, I bet you in Windows 10, there's a whole bunch of new ways to do this kind of stuff. So you'd be looking that stuff up, right? You want to go out and you want to look at something called IOCs. Can anybody tell me what Open IOC is? IOC? What is Open IOC? What's that? Open IOC. Anyone tell me what that is? Indicators of compromise. Very good, guys. Okay. So OpenIOC is an example of a framework where even though it's an XML, they're giving you the information so that you can look for this particular set of malware. So what you would want to be doing is you'd want to be taking these and adding these to your own signature list. So OpenIOC is one way of doing it. There's another one out there, and it's called IOC Bucket. So IOC Bucket is an aggregator of IOCs, right? So get out there and they grab IOCs from different places. There's another thing out there called Sticks. So Sticks is a similar project that people use for characterizing malware and writing signatures for stuff. And you're going to find that these are going to be the things you're going to be out looking for. Another one that we're going to talk about a little later today is called Yara. We're going to do Yara later today. But what you're going to be doing with each of these is trying to find as many signatures as possible, or as many classes of signatures, so that you can run this stuff against your malware and really quickly figure out what it is, how it works, what's it doing, so that we can start throwing it into a database and categorizing it. We're going to do that today as well. So let's stop right there. I'm thinking lunch. Let's grab some lunch. Let's go for about an hour, and we'll come right back and grab a little food, put some food in our bellies, and let's come back and let's do some other stuff. Let's see, what are we doing when we come back? Build a little bitty malware scanner, and we'll look at some embedded malware, and we'll do some Yara stuff. Okay. All right, guys, let's get some lunch. See you in an hour, guys.